Good afternoon, everybody. Welcome to class this afternoon. Thank you for joining me, whether you are watching here with me live or you are watching the recording. I appreciate you taking the time to watch this and learn some stuff from it, right? So as always, we're going to be using this time today to cover material for the next module. So this would be module 5 now that we're covering here. So as we get started today, it is key to note that your Module 4 assignments are due this evening by 11:59 p.m. So you want to make sure you get those finished and turned in. And we are starting Module 5 tomorrow officially, but we'll be talking about it today, right? So if you want to go back and review Module 4 material, make sure you go back and watch last week's video as you're finishing up your assignments for this week. And so we're starting out by talking about iteration for this module. Right? We're looking at the idea of iteration, and previously last week we looked at the idea of recursion. And the recursion was the first thing that we've really tried that will give us the ability to take our code and run it in a loop, run it over and over and over and over again, without any additional interference from us, right? Like we don't have to hit the run button again. We can just keep going. And so that's what we're working with today. As well is the idea of a while loop. And while loop is iteration, and iteration is just slightly different than recursion, right? It's a slightly different process, but it is another thing that gives us the means to take some of our code, run it over and over and over and over and over again, while not having any outside interference from us or from the user, right? We don't have to press the button multiple times. And so I think the first thing that's going to be huge for us to kind of understand is the idea of reassignment. Right, so in order for us to kind of talk about this, we're going to go back just a little bit and review some concepts that we've discussed for variables and other things previously, right? And just do a little bit of review. So in the past, we've talked about a variable, right? We said that we have a variable. When we establish a variable, what we are doing is we are creating a container. And on this container, we are putting a label. Right? So we're creating a container. And on this container, we're putting a label. And inside of this container, we're putting data. Data of some sort. Right? Could be a number, could be a string, could be a Boolean value. But once we do that, we have intrinsically linked this name with the data that's inside of this container, right? So when we reference this data later on in our program, we can reference it by the name that's on the container. Our interpreter will go back, grab this data that's in here, and bring it back out to our program and use it there. Right? So that's the general gist of a variable as we've considered it so far. But the other thing that's pretty critical about being able to use a variable is that not only can we put this data into this variable, but we can also take the data out of the variable. And in taking it out of the variable, we can replace it with something new. And the replacing of the data that's in a particular variable with something new is the process known as reassignment. So as you've kind of discovered, probably as you've just been working through things, right, it is possible to take this value or to take a variable and take the value out of it and put it into, put a new value in it. And so when we reassign a value from the point of reassignment, we change the value in that container. And from that point into the future, whenever we reference the name on that container, it's referencing the new value. Like what we see here on our slide mimics what we would see in the console panel. Let's see if we can refresh this here. What we would see in the console panel of our programming window, right? So that's kind of what we're doing here. If we write something like x equals 5, we've established that variable. We've put the label on that container that says this container is called x, and then we put that value of 5 in there. So whenever we refer to the value of x in the future, we get the value 5. Because we've established this bucket, we've put 5 in there, and we've given it a relationship with the name on the bucket, which is the value x. Right? But at any point, we can reassign a value to that variable. So at the point of reassignment, x is no longer 5. It's whatever new value we put into that container. And it's going to be that in perpetuity. Right? So that's a couple big things to note about reassignment right there. Right? One is that we can do it at any time. And 2, it's at the point of reassignment where the value changes, and it's going to be that value until we reassign the variable again, if we reassign the variable again. Right? So x will never go back to being 5 here unless we knowingly change the value through reassignment back to 5. And that's the idea we see being demonstrated here in our slide. We see x equaling 5, we see the reassignment, and so on and so forth. So it is an important point to bring up at this point, right? Because there is a common source of confusion that Python uses the equal sign for assignment. So it's kind of tempting to interpret a statement like A equals B as a mathematical proposition of equality, right? Because it seems to say that, oh, well, if we say A equals B, just like we would say A is greater than B, that must mean that we're looking for equivalency. That is incorrect. This interpretation is wrong. Because our single equals operator is an assignment operator. So when we say A equals B, we're not asking the question of whether or not A equals B. We are making the assertion that A equals B because we are assigning it. And I just inverted those letters there. You'd think I'd know better than that. We are assigning it to that value. So we are asserting A equals B there. If we want to check to see if one thing is equal to another thing, which is something that we'll look at a little bit later, we use our double equals sign. So single equals is for assignment. We'll spell it right this time. Double equals is for equality. Checking for equality. That's key to know. So when we update variables, one of the most common things that we've done here, or one of the most common things rather that we do in programming, is we will update the variable in relation to itself. Right, so like we see here with our first bullet point, we have x equals x plus 1. Right, so what we're saying there is that we're going to take the current value of x, and we are going to add 1 to it, and we are going to replace the current value of x in the container with this new value. Right, and that's why this kind of statement works. Because at this point, when our interpreter gets to this x, it has not completely evaluated this statement yet. So if we are working with this with a variable, we have a container with the label of x on it, we put the value of 2 in it. Right, so we get to this point where we're reassigning the value of x, but we haven't evaluated this entire statement yet. So at the point where our interpreter gets to this value x here, it says, oh, okay, I know the x variable's here. I can go get that 2, bring it back. 2 plus 1, that's 3. And we're putting it in where? Oh, we're putting it in the x variable. So that means I can take this value out of it and put 3 into it now. Right, so that's why that works. And we have a little shorthand for this, where we say plus equals, right? X plus equals 1. In some other programming languages, if some of you have experience with some other programming languages, you might know of the plus plus shorthand. This is Python's equivalent of the plus plus shorthand. Essentially what we're saying here when we're saying x plus equals 1, in long form is this same thing that we're saying here, x equals x plus 1. And we can make this value anything. We can make it 2, and that would mean that equals x plus 2. We can even use different mathematical operators here. So for example, if I use the multiply operator here, this would stand for x equals x times 2. Right, so it's going to get the current value of x, modify it in some way that we define, right? Like in the case of what we have in bullet point 1, it's going to add to it. And then it's going to update with a new value. Now, in order to do that, though, it is important to point out that you have to already have that variable defined. Right? Because if I don't have a value in x yet, I can't add 1 to something that doesn't exist. Right? So like we see in this case, in our third bullet here, we're assuming that x doesn't already exist. The first reference to an x variable in our program is x equals x plus 1. So if x doesn't already exist as a standard value that we can add to, then we can't add 1 to something that doesn't exist, so we get a name error, which is name x is not defined. Right, so we see that here. So we have to have some kind of variable in order to update it before we can kind of continue with it. And so when we're updating a variable by 1, we call that an increment or incrementation. And conversely, if we subtract 1, that's called a decrement or decrementation. Just some vocabulary for you all. So we said the while loop is a loop, and what exactly is a loop? Right, a loop allows us to repeat a process until a condition is met. And so each step through a loop is called an iteration. Now there is one important word here that I want to point out, and that's this one here, the word condition. Right? Last week we talked about conditionals. And in talking about conditionals, we said that, we're looking for a condition. If a condition is met, we run some code. If not, we skip that code and maybe move on to the next thing. Right? So in this case, we're still working with a condition. The only difference is that we're not just running it one time, like we would run it through an if statement. We're running it on repeat. So essentially what we're saying with a while loop, right, if you want to kind of expand this out and kind of think about it in a different way, whereas with an if statement, we're saying if this condition is true, do this. Whereas with a while statement, we're saying while this condition is true, or as long as this condition is true, keep on doing this. And so each step in a loop, each time the condition remains true and it executes the code, we call that an iteration. And loops are great for like running through an input and applying the same conditions to each part of it, right? So like if we were going to sort some values, right? We'll talk about sorting algorithms later on in the course and work with different data structures and things like that in terms of being able to sort things. That's one thing where iteration is great. However, speaking of iteration, let's talk about iteration just a little bit more. Right? Iteration means executing the same block of code over and over and over again. Right? Potentially many times. And it's a programming structure that implements, and so we call a programming structure that implements iteration, we call that a loop. Right? So there are different types of loops, right? A while loop is just one type of loop. But among these different types of loops, we kind of have these two umbrella types of iteration: indefinite iteration and definite iteration. And with indefinite iteration, the number of times the loop is executed isn't specified explicitly in advance. So it could run forever, feasibly, if the condition is never met. So in this case, the designated block is executed repeatedly as long as some condition is true. This is what we're working with a while loop. However, with definite iteration, the number of times the designated block will be executed is specified explicitly at the time the loop starts. So since we're only covering while loops at the time being, while loops qualify as indefinite iteration. Right? Because they're just going to keep running as long as some condition is met. Now, if we break that condition, then it'll stop. But it can run for an indefinite amount of time. In the next module, when we start looking at string manipulation, we'll look at some other ways to execute iteration, and we'll execute definite iteration. And so with all that background information, let's start talking about the while loop. With a while loop, we can execute a set of statements as long as or while a condition is true. So it's very similar to an if statement. And here's an important part about this, is that the while loop requires relevant variables to be ready. We call this seeding the loop, and this is very important because in order for it to be able to run, you have to initially have that condition be true. Right, so let's head over to a REPL window here. And let's just start running some code, shall we? And let's just do a really basic while loop, and we'll set it up, in the manner that we're supposed to set things up. So I'm going to zoom in. I'm going to start off with my shebang here, hashbang /USR /bin /env Python 3. And we're going to create a function here. And we're going to call this a def counting. So we're going to create ourselves a function. We're going to call it counting. So we want to count from 1 to 10. Right? Let's just start a function where we're just counting from 1 to 10. So we need to have a while loop that starts with a true condition. So ideally, we'd want some kind of starting point, right? We'll just call this variable start, just so we can kind of easily delineate and easily examine like what our starting variable is, like these different pieces of what we need for this while loop to work. We'll start our variable at, or we'll put our starting variable at 1, and since we want to utilize this function to count from 1 to 10, we'll start at 1 because that's where we want to count to. And so the next thing we need to do is we need to define our condition. Right? So 1, we're going to write while, because it's our while loop. So we start with our while keyword, while the value of start is less than or equal to 10. Right? And so what we see here is we see similar syntax to what we were working with, right? When we were working with recursion last time. Or not, with our conditional statements, which we also worked with in conjunction with recursion, but with our conditional statements last time, right? Like when we were writing a conditional, we would just write if whatever, like if start is less than or equal to 10, then we'll do something else. And that something else here is indeed something that belongs to this function. Right? So we use a colon at the end of the line, just like we would use a colon at the end of the line, our if statement. Remember one of the things that we said last week when we talked about our if statements was, and we said it before with our functions, right? Just to kind of reiterate this over and over and over again. If we have some kind of statement, like our while loop statement here, that ends with a colon at the end of the line, that means that this is going to have more lines of code that belong to it. And just like with our function, and just like with our if statement, both of those, because both of those lines end with the colon, anything that belongs to that statement. So any code that we want to run as a part of this loop has to be indented in under the loop. And so our IDE is going to indent it in automatically, right? Like you can see where my cursor is there. You can see that it's tabbed in another level from where it was. Right? You see the start of the word while, and you see where my cursor is now. You can see that it's tabbed in more. And so this is where we start to have to pay extra attention to our logic in Python, right? Because the more statements that we add that have colons at the end of them, that have other code that belongs to them, right? We could be getting several different tab layers deep, right? Because I can put if statements inside of while statements inside of functions, and I can just nest them deeper and deeper and deeper, right? So I have to pay extra close attention and make sure that I'm on the right level where I want my code to be when I'm writing it, so I know what it belongs to. So I'm going to do two things here, right? I'm wanting to use this to count from 1 to 10. So I'm going to print the current value of start. Right, so at first it's going to be 1. Right, but then just like with our iteration, or rather just like with our recursion last time, with our iteration, we have to be able to take this starting point and move it to our ending point in order to break our condition. In this case, it's when our starting value becomes greater than 10. So I need to be able to add 1 if I want to count from 1 to 10. I need to be able to add 1 to start. So start plus equals 1. And remember, that's the same thing as saying start equals start plus 1. So what this will do then is, now that it's at the bottom of the while statement, it's going to jump back up to the top of the while statement and check the value of start against the condition again. So the first time through the loop, right, we're starting our start variable at its starting value. So we're starting at 1. We're printing the value 1. And then we're incrementing the value to 2 and restarting our loop. So the second time through our loop, start begins at the value of 2 because we've incremented it here. We're printing the value of 2, and then we're incrementing the value of start again. So it goes from 2 to 3 and jumps back up to the top of our loop. And we see this continue to happen until we get to a point where our starting variable no longer meets this condition that is defined in our while loop. Right? So once we get to the point where eventually it's going to be 10, right? We'll have our start value at the top of our while loop at 10. 10 is less than or equal to 10, so that's true. So that'll print 10, but then it'll increment start to 11. It'll go back up to here. And at that point, 11 is no longer less than or equal to 10. So it'll not run anymore. It'll be finished. So let's invoke this function behind our main gate. If underscore underscore name underscore underscore equals main underscore underscore, we will invoke our counting function. So now we have our invocation of our counting function locked behind our main gate. Since this is the file that we're going to be running, it will run what's behind our main gate. It'll run our counting function, which will cause it to come up here and trigger our loop. So if we run this now, we get to count to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let's look at this just a little bit differently. Right? And let's add something else to this to make this a little bit fancier, right? Let's use our function to bring in an ending value. So I'm going to bring it in as an argument. So now we won't have a predefined 10 here. We'll have an ending value that we'll bring in. And we'll say, while start is less than or equal to end, we'll print start, we'll add 1 to start, and everything will be just fine. So this gives us a little more flexibility, right? Because if we take our ending value in as an input, and we pass that to our function here, we can count as high as we want. So in this case, right, we'd create an input. We'll use a variable for it, call it num equals int of our input. Enter a whole number. And then we can just take our num variable and put it in as the argument in our counting invocation here. So now whenever we run this function, it gets the num here, converts that into an integer, passes that into here, which will then send it through that pneumatic tube that we talked about previously into our function, so we can use it as the endpoint that we can count to. Right? So now if we run this program now, we get asked to enter a whole number, like say 15, and we can count from 1 to 15. Which is looking pretty nice. Right? And every time we run this, we can run it to a different number, right? Like here's 50. And it counts to 50. So we see that work there for us. So now that you've seen this work a little bit, right, and you've seen something actually kind of function here, let's talk a little bit about what's going on here. Let's talk about the flow of execution for a while loop, right? So we can talk a little bit more about the theory behind what's going on here. Because in our flow of execution for a while loop, what we're doing here is we're evaluating the condition, right? So we have that condition that's along with our while statement, and we're saying as long as this condition is true, we are going to run this code that belongs to this while statement. And so if that condition is true, we're going to execute the code that belongs to that while statement and then jump back up to step 1. But if that statement is false, we're going to skip the body of the code and go down to whatever's next in our program. Right? So if we were to visualize that, right, we see it like this. Right? We enter into a while loop, we have a condition. As long as that condition is true, we see that we run the statements inside the while loop, and then we jump back to the condition to check it again. If that statement is false, we bypass all the code in the while loop and just move on to the next thing. Right? And so here's some similar syntax to what we've already seen. And so we want to make sure that we see several things here, right? Because there are key things here that we need to notice. Right? And one is that we have a starting value here. Right? In this case, it's I. I equals 1. 1 is our starting value. And we're saying as long as whatever value is in our I container is less than 6, then we are going to print the value that is in I. But now if we just did this without the very last line there, where we're doing our incrementation, what we wouldn't be doing there, and let's just imagine this for a second, shall we? Like, let's just imagine for a second this last line here did not exist. Right? Because that will run. That's a valid loop, right? The problem here is the same problem we would run into last week when we talked about recursion. Right? Because if we don't move this point toward this point, and we don't have anything else in our code that will break this condition, then this condition is going to stay true forever, and you will end up in an infinite loop. And we don't want an infinite loop. An infinite loop will error out our program. Right? It'll trigger Python's infinite loop protection, and it will cause our program to stop running and error out. So we need to be able to take our code, take our variable values, and move them from the starting point to the ending point. Right? We need to be able to increment these, one step at a time, 2 steps at a time, some sort of step at a time, to be able to get us from our start to our end, so it will stop running what's in this while condition. That is absolutely critical. The other thing to notice here is that when we're starting this loop, we're always going to start our while loops with a true condition. Either that or, sometimes we might not, like if we just want something to run multiple times if our user enters it in. But if we want our code to actually start and actually work, we have to start it being true. Right? Which is why we set this I variable to start at 1 here. Because we want this code to run. So we start it with 1. Right? First time through the loop, I is 1. Then we add 1 to it. It becomes 2. So it goes back to the top. I becomes 2, 3, 4, 5. When we run 5 through the loop, 5 is less than 6. So we're going to print 5. And then we're going to get here to this point where we're going to say 5 plus equals 1. That turns I into 6. And at this point, this will stop running. Right? Because because 6 is not less than 6. 6 is equal to 6, which would cause this here to be what would be printed out to the console. It would say 1, 2, 3, 4, 5. But the process of starting our loop in a true condition, we call that seeding our loop. Seeding our loop. So when we're writing a loop, we want to be able to give ourselves a starting place that's going to make that condition initially true. And, something that's kind of been common that I've seen in the past is that you'll try to start a loop, you'll try to create a loop without establishing that starting point, without establishing a physical value that's going to be that starting point. Now, let's talk about how we can seed the loop and do some different examples here of that. So let's have a look back in our Replit file here. I'm going to put this in another. And we're going to call this Boolean loop.py. Right, so we're going to have another file here that we're going to put a Boolean loop in. Right, so remember, again, you don't have to create multiple files, right? We're just doing this to kind of keep things separated here. So I can put multiple examples into one file and just have it linked to you all. I encourage you all to do do all of your work in the main file in Replit. It's much easier while you're learning to do it that way. But I'm going to add my shebang. And I'm going to add a function here that's going to be my new loop. And so we're going to do something just a little bit differently here. We're going to call this the echo input function. And in this case, we're going to make what we call a flag variable. And a flag variable is a Boolean variable. So we can just we can call this start loop, and we can set it to true. Right? Remember, we talked about our Boolean data types before. A Boolean value is a value that is either true or false. In Python, we represent them as the word true with an uppercase T and the word false with an uppercase F. We can see here that there is no quotes around these, so it's not a string. It's its entirely separate thing. It's a Boolean value. And so what we've done here, in essence, is we've created a value that will seed a loop. Because we have a statement here that is always going to be true. Because it literally is true. Right? So we can write a while loop here that just says while start loop. And so that's kind of shorthand for saying while start loop equals true, right? Because we're looking for this to evaluate to true anyway, right? And we already know it's true because it literally is true. So while it's true, we'll just take a regular variable x, set that equal to the input of enter something here. And then we will print x. At our main gate. And run our function, echo input. And so what we've done here is we've created an infinite loop, but this is also an infinite loop that won't trigger infinite loop protection in Python because we have this interstitial step here of the input step. So this will be something that we can just keep continuing entering words into, and it'll keep echoing them back out to us. Right? So remember when we run another file in here, we have to go into the shell instead of the console and run Python boolean loop.py. So we can enter something here, something. It echoes it back out to us because that's what we tell it to do. And it'll let us keep doing that in perpetuity. Now, the problem here is that we don't necessarily want to do this forever, right? Like there are some types of programs that you would use for like logic controllers and things like that, where you always want to be reading like a value from a sensor every 5 minutes or whatever, and then pass that value to something else. And you don't necessarily want that to stop. But for a program like this, we want to be able to stop. So we want to be able to look for some word where if that's the word that's been entered, then we can take and we can flip our flag variable from true to false, which means that our loop will stop running. Right, so in this event, what I might want to do is add a conditional statement here under my input and say if x equals stop, well, we'll just take that start loop variable and reassign that to be false. So now, again, by its very nature, start loop is false because start loop would literally equal false at that point, which means that this while loop would no longer run. And if we put this print statement behind an else condition, which means we'd need to tab it in one here, then if we enter in anything other than stop rather, it's going to echo it back out to us. Right, so let's try that again. And we might need to Control C. So we're going to run Python boolean loop.py again now. And now we can enter something else, whatever we want. But if we enter the word stop, it's going to stop. So in this case, that's what we did to break that while condition. We want to do something to break that while condition. right? Breaking that while condition is super important. There's another thing we can actually do here that would make this a little bit different. And it's a little more literal, and that is to use a break statement. So with a break statement, we can stop a loop even while the condition is true. We break out of it, right? Just like I've been using the word break. So if we stop the function with a break, or we stop the while loop with a break, it's going to break out of the loop just as if it was false, even if it's still true, right? So in this case, like what we have here, I equals 1 while I is less than 6, print I. If I equals 3, then break. And then I plus equals 1. So the first time through this loop, I is 1. You add, it's not equal to 3. So you keep going and you say, well, I is plus equals 1. I becomes 2. 2 is less than 6. So we print 2. 2 is not equal to 3. We add 1 to it, and then it becomes 3. 3 is less than 6. We print 3. But 3 is equal to 3. So the program would stop there. The while loop would stop there, and it would break. Right? So we can see that in action with our program here. If we took this start loop equals false, and we replaced it with the statement of break. So now we're not going to literally make this statement false. Our start loop is always going to be true, but we're going to break our loop in the event that somebody enters stop. And let me just add that to my input here, or stop to stop, right? Because like we've said before, whenever we are adding inputs to a program, we want to be specific so that our user knows what they're supposed to enter in. So we'll run that again. Enter something here or stop to stop. Something else, another thing, whatever. And then we can stop, and it stops, right? It breaks out of that loop. And the thing to note there with our break statement is that start loop never became false, right? Start loop is always true. Start loop, we're not reassigning the value of start loop here. So it's never going to be anything other than false. Now, we still had to make start loop true in order to seed this loop and let the program run to begin with, or else it would never run. Right? But when we're using a flag variable like this, or really when we're using any sort of conditionals inside of a loop, a while loop, this is another option that will allow us to get out of our while loop. Let's look at another way to do a while loop that's going to be pretty similar. So I'm going to make another new file here, just so I can have a separate file here for you to look at. And I'm going to call this one string compare loop.py. So we're going to compare a string with this one. We're going to add our shebang, usr/bin/env Python 3. And we'll create a function, def string compare. And in here, we're going to create another seed variable, right? And we're going to call this one y. This process is going to be very similar, right? So we can call this like continue equals y. So this is just another way to seed our loop. So in this case, I can say while continue equals y. We can collect an input, so we can take x, or let's create a numerical input. We'll call it num, and we'll set that equal to the integer typecast value of the input. Enter a whole number. And so let's use this to make a square of asterisks, like an asterisk cube. So it'll take and print a certain number of asterisks a certain number of times, whatever number is defined by our user. So this will also allow us to nest a while loop here as well. So what we might want to do here is to create another counting variable for rows. We'll call this row, and we'll set it equal to 0. And we'll say while row less than num, we will print the string of asterisk times our repetition operator to the value of num. So we're going to repeat that num times, and we can put some spaces around that. And then we can increment our value of row by saying row plus equals 1. Break out of that while loop just by going backwards. And we can ask our user another question. And we can say continue equals input. Would you like to go again? Y/n to imply yes or no. Right, so if it's yes, continue remains yes, it jumps back up here. Continue is y. It runs all this again. If it's n, it stops it. Right, so now let's give this a try. We can Python string underscore compare underscore loop dot py. Oh, you know what? Continue is a reserved keyword. That's why that's not working there. So I need to change that to something that's not a reserved keyword, so that'll work. Some of you probably caught that. And we need to invoke this function behind our main gate. We're getting a little bit ahead of ourselves. It's getting real late in the day. I'm getting a little forgetful. If underscore underscore name underscore underscore equals main, we want to invoke string compare, and we'll run that. But we don't want to run that. We'll stop that. Because that's running out of our main.py. We want to run out of our string compare.py. So we'll run that. Enter a whole number. Let's enter 10. And there's our cube, right? We get 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 across. With 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 down. Right, so not a cube because it's not 3-dimensional. It's 2-dimensional. It's a square. And so from here we can choose, would we like to go again, yes or no? If I say y for yes, it's going to start over again. And it's going to tell me to enter another whole number. And I can enter 15. I can enter whatever I want. I get this bigger square here. And then if I say no, or really anything else, right? Because at that point, continue or cont is not y, it's something else, that's going to break our initial while loop and it's going to stop our program. Just like that. Right, so that's pretty big, pretty critical. Now, why couldn't I use the word continue here? We said it's because continue is already a reserved keyword in Python. It's actually a reserved keyword for loops. Because with our continue statement, we can stop the current iteration and continue with the next one. So this is kind of interesting, right? Being able to use this continue. It's basically a way for us to kind of not do something in the middle while our statement's still true. Right? So if we examine this series of statements here, we can look at it in three ways. We can look at it as what the value of I is, and whether or not I will be printed. So the first time through the loop, we seed our I at 0. So the first time through our loop, the value of I is 0. And I is not equal to 3 here, although we're incrementing it here. So let's also include our increment value. So I is equal to 0. We start out with I at 0. We increment I to 1. At this point, I is reassigned to 1. 1 is not equal to 3, so it's going to skip that if statement, which will cause it to print. Now I is 1. That's going to increment immediately to 2. Here, 2 is not equal to 3. So that's going to cause it to print. 2 is going to be the start of the I value at the third iteration through. That's going to increment to 4. 2 is going to increment plus 1 to 3. 3 is equal to 3, which means we're going to hit this continue statement. Which means we're never going to get to this print statement in our third iteration. So 3 will not print. And it'll just jump right back up to the start of our next loop with the value of I is 3, which will then increment to 4, which will then print. The next loop, it's 4, which increments to 5, which prints. The next loop, it is 5, right, which passes our condition here, 5 is less than 6, which increments to 6 and prints. Within the next time through, it becomes 6. 6 is not less than 6. 6 is equal to 6. So the output that we would expect from this while loop here is 0, 1, 2, 4, 5, 6. Or actually, we wouldn't get 0, right? Because we're incrementing before we print. So we'd get 1, 2, 4, 5, 6. So it's just going to skip 3 like it didn't exist, right? Wherever that continue statement is, once it hits that, it's just going to jump back up to the top and continue like normal. The important thing to note out of this, though, is that we have incremented it before we get to that continue statement. Because otherwise it would be in an infinite loop, right? It would just continue forever. Right? So we need to have that place where we're incrementing it before we hit that continue. So the last thing that we have here really that I want to cover today is this else statement. Right? So we can even utilize an else statement with a while loop. That's just like using an else statement with an if statement. So when that while condition becomes false, it will trigger this else condition instead of the code that's looped under the while condition. And it'll only run that one time. Right? There's no such thing as an elif with a while loop, right? There's no such thing as an else while. but we can use an else. So like if we were to go back into our program here, at this point, we can run an else. I need to be able to tab that over so it's on the same level as its accompanying while statement. And I can just have it print out something like, thank you. Clear this out, and we'll run this again. So as long as we enter numbers and say yes, we can keep going. But when we say no, is that on the right level? Because it should say thank you there. That is right. Maybe it was just not updating the file when I ran it here. But that's what we would expect there, right? Whenever that while loop becomes false, it's going to jump to that else statement and run that else statement. And this program here is also a big hint for all of you watching. That's going to be key for one of your lab assignments for this module. Now, with that being said, I want to do something a little bit different this week. I've got a code challenge for you. And if you email me your code challenge and you get it correct, or you get it at least mostly correct, I'll give you some extra credit on the major lab for this week, which would be the number pyramid lab. Right, so let me get this code challenge pulled up here. And we'll talk about it, and then we'll end the stream for today. But this code challenge is called Judging Moose. And if you do this properly, this will take everything that we've learned so far, everything that we've learned up until this point, and apply it in one program. So you're going to need stuff from Module 1, you're going to need stuff from Module 2, you're going to need stuff from Module 3, Module 4, and Module 5 to be able to answer this. And in order to qualify for the extra credit, I want you to email your replit to me before 11:59 p.m. next Thursday. So whenever this module's due, this extra credit's also due. You can choose to do it or not, right? It's not going to count against you. Only if you email me the link to your replit will you be eligible to earn the points. Then it'll also have to work, right? And so what you might want to do here is you might want to kind of pause or stop and, look at these program briefs and see what happens, right? Write down some notes and go from there. So here's the program brief. You've been contacted by NAP, National Alcis Pageants. The Alcis is the scientific genus or something like that for moose. I was just coming up with something clever. To create a program for their moose beauty pageants. NAP has nice moose beauty pageants. One of the things they need to automate is the antler portion of the beauty pageant. So the judges need to be able to count the number of tines that are on the moose antlers and give them a score based on certain criteria. Now we can see the moose down here in the corner. We can see the tines here. The tines are the little points that are on the moose antlers here. And so this is the criteria. And this will be where you might want to pause or take a screenshot of this, or do something with this to where you can kind of keep this, right? You're going to need to take two inputs. One is the number of moose being judged, and the other is the total number of tines for each moose. Right? So you're going to need a loop to be able to enter in the number of tines for each moose, right? You're going to want to be able to loop your program to give a score for each moose. So you're going to take two inputs. You're going to take the number of moose being judged, and then you're going to loop the input of being able to take the number of tines for each individual moose. So if the first moose has 10, you need to have 10 and be able to evaluate 10. Second, 11, or whatever, so on and so forth, right? And so with each of the inputs that is entered in, you're going to determine whether the number of tines is even or odd. If the number of tines is greater than 7 and even, print great moose. If the number of tines is greater than 7 and odd, print good moose. If the number of tines is less than 7 and even, print okay moose. If the number of tines is less than 7 and odd, print fair moose. If the number of tines is 0, print not a moose. Execute this judgment for each moose in the predetermined number of moose that are being judged. That is your task. Write that program, make it work. Submit the replit to me via email by 11:59 p.m. next Thursday in order to be eligible for the extra credit. I will be divvying extra credit points based on how many people turn it in. So the more people that turn it in, the fewer extra credit points you'll get. The fewer people that turn it in, you will reap the rewards. That just remains to be seen. So that's all that I have for you for today. We'll turn the music back on for a few minutes, just in case anybody who's here with me live has any questions. Module 5 will start officially tomorrow. That's all that I have for you for today. Thank you for watching. We'll see you next time.